Okay, so this is going to be our lecture on nomenclature, or the naming of our organic molecules. So you've heard these names tossed around in lecture and in lab. We have a systematic way of going about naming organic molecules, which we call our rules of nomenclature. The basics of nomenclature is that a name will point you uniquely to a molecule. Likewise, a molecule has a unique name, right? So we can distinguish between what exactly it is that we're talking about based on the name of that molecule. And we're going to start with our first functional group in this course, alkanes. Okay. Remember, an alkane is carbons and hydrogens, all single bonds. That's our first functional group that we study in the course. For every functional group, one of the first things we're going to learn how to do is name those molecules. The rules that we lay out here for alkanes, we're going to kind of just rinse and reuse them when we encounter a new functional group in the future. We're just going to tack a little bit more extra on to each one of these rules, but they'll have the same basic structure. Okay, so first thing we need is we have these prefixes that refer to the number of carbons that are in a given molecule. All right, so if we have a molecule, we can tell how many carbons it has based on these prefixes. So 1 carbon, we use the prefix meth. For 2 carbons, we use the prefix eth. For 3 carbons, we use the prefix prop, and for 4 carbons, bute. Okay, these first 4 here are very unique to chemistry. After that, it follows, I think, Greek prefixes, but what you've sort of heard of from your geometry course as well. 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. Okay, and truthfully, we can go up to 11, 12, 13, 14, whatever. These are the 10 that I expect you to have memorized for this course. Again, meth, eth, prop, and bute. These ones are fairly unique to chemistry. These are the ones that I think you want to focus on because they're kind of the hardest to remember. And then once we get to 5 or more, it follows our normal geometry. Pent is 5, hex is 6. 7 is one that students tend to forget. They want to say sept or something like that. Importantly, it's hept, H-E-P-T. 8 is oct, 9 is non, and 10 is dec. Okay, so we can figure out how many carbons we have based on these prefixes here. Okay, so we're going to have the same 4 basic rules for naming molecules. We're always going to have these same 4 first steps. And the first step is to find what's called the parent chain in that molecule. All right, so when we're looking at a molecule, we're going to find its parent chain, which is the longest continuous set of carbons that we have in that molecule. We're going to use our number of carbons prefix for our parent chain to describe how many carbons there are. And different functional groups have different suffixes that you're going to use, different endings that you'll tack onto the end of the name. For alkanes, which is our first functional group, you're going to use the ANE ending. So your number of carbon prefixes plus that ANE ending, ane. All right, so let's just do some examples here. These are some straight chain alkanes here. All right, so we can name these based just on that first rule. We need to find how many carbons are in our parent chain here, our longest continuous set of carbons. So in this first example, we have 1, 2, 3, 4. So that number of carbons prefix that we're going to use for 4 carbons is bute. All right, and then we're going to tack that ANE suffix on there. So this molecule here would be butane. All right. This next example, 1, 2, 3, 4, 5, 6, 7. So we're going to use that prefix hept and then that suffix, because this is an alkane, of ane. So this is heptane. All right, so I want you to take a second pause and finish the rest of these examples here based on what we've just discussed. All right, so this molecule here with 3 carbons is propane. If you have a gas grill at home, it's powered by propane. That's this molecule here. This is what you're igniting to create that flame in the grill. All right, whoops. So number of carbons, 1, 2, 3, 4, 5, 6. So this molecule right here would be hexane. This molecule right here with its 2 carbons, ethane. And with just 1 carbon, as in CH4, this is methane. All right, they have that ANE ending and our number of carbon prefix. Okay, so these were particularly easy examples because they're just straight chains. How do we deal with molecules that have branch points? All right, so our first step is the same as what we just discussed. We need to find that parent chain. It's the longest continuous set of carbons. So what we're going to do is we're going to count 1, 2, 3, 4, or 1, 2, 3, 4, 5. Since this is my longest set of carbons here, this is the parent chain of that molecule. Okay, so my parent chain here is a pentane. But again, the whole logic of nomenclature is that we've accounted for everything in this molecule here. So how do I account for this extra carbon here? Okay, what's sticking off of your parent chain is what we call a substituent. And rule 2, the next step in nomenclature is to find and name all of your substituents. All right. We're going to introduce new substituents as we go on through the course, but for right now we just have alkyl substituents, meaning all carbons and hydrogens, all single bonds. All right, that's what an alkyl group is. And what we're going to do is we're going to name that alkyl group using those same number of carbon prefixes that we looked at before, but then we're going to tack on the suffix YL. All right, so if we go to this example here, we got our parent chain accounted for, we got these 5 carbons accounted for, and now this one up here, my substituent sticking off of the parent chain, is a methyl group. All right, we have that YL ending, our number of carbons, meth, because it's just 1, and then that YL ending for an alkyl group. Okay, so this is going to go out front of our name here, but we're not quite done yet. We have to tell where on our parent chain that substituent is, where that methyl group is on that pentane parent chain. And we're going to do that by numbering our parent chain. All right, so when we go here, we're going to number our parent chain. Carbons 1, 2, 3, 4, and 5. So our methyl group here we can see is on carbon 3. And the last step is to assemble our name, put everything together, and we do that with the locant, the number of our carbon where our substituent is, followed by our substituent name, and then the parent chain all run together, all right? All one word here. So this, with our methyl group on carbon 3, would be 3-methyl pentane. All one word, all run together here. All right, so let's go to this next example here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in our parent chain. And we have 1, 2, 3, 4 carbon substituent here, or a butyl group. So my parent chain with my 9 carbons, this is a nonane parent chain. I've got this butyl group, and now we have to number our parent chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 butyl nonane. Again, all run together, all one word. Okay, let's go on to our next example here. We have to find our parent chain. So 1, 2, 3, 4, 5, 6, 7. But that's not our longest continuous set of carbons. All right. We could have 1, 2, 3, 4, 5, 6, 7, 8. So this is my parent chain here. All right, meaning that this 2-carbon substituent sticking off of there is an ethyl group. All right, so my parent chain is an octane. I have this ethyl group. Where is that ethyl group located? All right, so up until now, the previous examples, you could have numbered either way and you would have gotten the same answer. In this case, it's going to depend on which direction we number our parent chain. So I could go this way, 1, 2, 3, 4, 5, 6, 7, 8. Or I could go the other way, 1, 2, 3, 4, 5, 6, 7, 8. So which one of these two numbering schemes is correct? Importantly, when we number our parent chain, our rule for numbering our parent chain is that we want the smallest possible number in that name. Oops. Okay? So when I go to my two options here, I'm going to have to decide which one of these numbering schemes is better, the red one or the blue one. If I use the blue numbering scheme, I'd have a 5 in the name. If I use the red numbering scheme, I'd have a 4 in the name. We want the smallest possible number, so that's why we're going to pick our red numbering scheme here. Okay, so this would be 4 ethyl octane. All right. Let's go on to our next example here. Okay, again, I need my parent chain, my longest continuous set of carbons. That would be these 7 here. All right, so my parent chain is a heptane. I've got this 1-carbon substituent on there, a methyl group. I'm going to number my parent chain. We can always number in 2 directions here, 1, 2, 3, 4, 5, 6, 7, or going in the reverse direction. So which one of these numbering schemes am I going to pick, red or blue? Again, I want the smallest possible number in my name. If I did the red numbering scheme, it would be a 5-methyl. If I did the blue numbering scheme, it would be a 3-methyl. So we're going to pick the blue numbering scheme, the lowest possible number in our name. All right, so 3-methyl heptane. Again, all run together, all one word. All right, so what if we have multiple substituents? So in this case here, 1, 2, 3, 4, 5, 6, 7 is my parent chain. I know my parent chain is a heptane. Let me make that less ugly. All right. I have over here is an ethyl substituent. And over here is a methyl substituent. All right, let's number our parent chain. Well, if I did this way, 1, 2, 3, 4, 5, 6, 7. If I picked my blue numbering scheme, I would have a 3 and a 6 in the name. If I go the other direction, I would have a 2 and a 5 in the name. So which one of these do I want to pick? Again, I want the lowest possible number in the name, so we're going to pick our red numbering scheme. All right, we don't want the blue, we want the lowest possible number in the name. Okay, so then how do we sort of build this together here? Our last step is to assemble that name. Now we have multiple substituents. So if we have multiple substituents, we're going to arrange them in alphabetical order when we put our name together. So I have my methyl group on carbon 2, my ethyl group is on carbon 5, but F, the E, comes first in alphabetical order. So this would be 5 ethyl, all right, 2 methyl, gonna run out of 2-methylheptane. All right, so we have arranged our substituents in alphabetical order in our name. All right, you can note that we always have a dash between the number and the letter in our naming scheme here, right? So dash to dash methyl. All right, so here, everybody take a second, pause the video, and try to name this molecule for us. Okay, importantly, my parent chain here, 5, 6, 7, 8. That's my longest continuous set of carbons. We have this 3-carbon group, which is a propyl group. We have this 1-carbon group, a methyl group. We're going to number our parent chain. All right, if we use this numbering scheme, we would have a 4 and a 6 in the name. If we went the other way, we would have a 3 and a 5 in the name. So again, we're going to want to pick that red numbering scheme. Get rid of blue here. Okay, red beats blue. So when we put this together, though, we need to put our substituents in alphabetical order. M comes before P in alphabetical order. So this would be 3-methyl 5-propyl, and then that parent chain, octane. All right, so in our nomenclature, we've accounted for all carbons that are in our molecule. We first found our parent chain, the longest continuous set of carbons. Anything sticking off of that parent chain is a substituent. We're going to name that according to how many carbons are in that substituent. And then lastly, we're going to indicate where that substituent is on our parent chain. All right, so now let's talk about some more specialty examples here, okay? Sometimes you can find 2 parent chains that are tied, right? The same number of carbons. Let me just show you an example. So here we could have, let me make a copy of this actually. All right, so we could have 1, 2, 3, 4, 5, 6, 7, 8. Or we could have 1, 2, 3, 4, 5, 6, 7, 8, and we're tied, right? We have the same number of carbons regardless of which numbering scheme we picked, but we would get a different name because we have these different substituents here. So which one of these 2 is correct? All right, so if we have a tie with our parent chain, we want the longest continuous set of carbons, but we got a tie. We're going to break that tie depending on the number of substituents. So our parent chain, we're going to pick our longest continuous set of carbons. If there's a tie, our parent chain is going to be the one with the most substituents sticking off of it. So in this case here, this has just 1 substituent. Whereas if we pick this one, we have this and this, these 2 substituents. All right, so this is going to be our correct parent chain here, not the one down at the bottom. So I'm just going to get rid of that. All right, so in this case, we have this propyl group and this methyl group. We're going to number our parent chain 1, 2, 3, 4, 5, 6, 7, 8. Or we can go the other way, 1, 2, 3, 4, 5, 6, 7, 8. If we did our blue numbering scheme, it would be a 2 and a 4. If we did our red numbering scheme, it would be a 5 and a 7. So which one are we going to pick? We want that blue numbering scheme. All right, so let's get rid of these. Okay, so our name here that when we assemble it in alphabetical order would be 2 methyl, 4 propyl, and then that parent chain, octane. All right, so everybody take a second, do this one for me. Pause the video, name this one, and then we'll do it together. All right, so importantly, my parent chain here, there's a tie, but if I go this direction here, I have my maximum number of substituents. So that means that this is a substituent, a 2-carbon substituent, an ethyl group, and this one's a 4-carbon substituent, a butyl group. All right, and we're going to number our parent chain in this direction here so that we have the lowest possible number in the name. When we assemble, we're going to put these in alphabetical order. So this is 5 butyl, 3 ethyl, and that parent chain, my nonane. All right. So last few specialty cases here. What if I have multiple substituents that are identical? So in this case here, our 5-carbon parent chain, and this is a methyl group. But this is also a methyl group. All right, when we have multiple identical substituents, when we're arranging our name, we're going to use these prefixes, di, tri, tetra, penta, etc. So in this case, with my 2 methyl groups, I'm going to use this di prefix here. All right, so let's just show you. First of all, I guess let's take a step back. We got a number here. In this case, you can convince yourself whether you went in either direction, you would get the same numbering scheme. All right, a 2 and a 4. So when I put this together here, I'm going to say 2, 4 dimethyl pentane. All right, I have a methyl group on carbon 2 and a methyl group on carbon 4, so that's the dimethyl, and then my parent chain, my pentane. All right, so let's do this one here. My parent chain is going to be my butane here. All right, again, I have these 2 methyl groups. This is a methyl group. This is a methyl group. And they are both located on carbon 2. Importantly, we need to include the number, the locant of both of those methyl groups, even though they're on the same carbon. We need to include the locant of both methyl groups. So this would be 2, 2 dimethyl butane. All right, so multiple substituents, multiple identical substituents. We're going to use these prefixes, di, tri, tetra, etc. You need to include the locant of both of those substituents, even if they're on the same carbon. All right, and then our last example here, the last kind of specialty rule we need to keep in mind. Okay, we find our parent chain, 1, 2, 3, 4, 5, 6 carbons. This is a methyl group. And this is an ethyl group. We're going to number our parent chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So notice if I did my red numbering scheme, there would be a 3 and a 4 in the name. And if I did my blue numbering scheme, I'd also have a 3 and a 4 in the name. All right, so we're tied. So how do we break a tie? All right, if and only if you have a tie in your numbering scheme, then numbering our parent chain, we got one more rule, and that is to break a tie, you're going to use alphabetical order. All right, so In this case here, we have a tie. So we're going to break that tie by using alphabetical order. Since ethyl comes before methyl in the alphabet, we're going to give that ethyl group the lowest possible number. So that means we're going to use our red numbering scheme here. So if and only if there's a tie, you always go for the lowest number in the name. But if and only if there's a tie, you break that tie with alphabetical order. So this would be 3-ethyl, 4-methyl, and then my parent chain, that hexane. All right, so then everybody pause the video, take a second, do this last one for me here, this last example. All right. My parent chain being those 9 carbons. I have a propyl group. I have a methyl group. And I have a butyl group. If I did my numbering, or I could go the other way. If we did our red numbering scheme, it would be a 4, a 5, and a 6 in the name. If we did our blue numbering scheme, it would be a 4, a 5, a 6 in the name. So again, we have a tie. How do we break that tie with alphabetical order? Notice that my butyl group is on the same number regardless of which one of these I pick, right? So we're going to have to look here for our breaking of our tie at the methyl and the propyl group. In this case, M comes before P in the alphabet. So we're going to use that numbering scheme that puts my methyl group on the lowest number, that blue numbering scheme. All right, when we put these in our name, we're still going to arrange them in alphabetical order. So that would be 5-butyl, 4-methyl, 6-propyl, nonane. Okay, so our nomenclature of our alkanes, and really our nomenclature for all of our all molecules that we're going to encounter. We got these same 4 steps. Step 1 is to find our parent chain, the longest continuous set of carbons that are in that molecule. Again, we've only introduced alkanes here. They have that suffix ane, ane. What you're going to find is every time we introduce a new functional group, we got a new suffix that we got to learn. But it's same 4 steps, right? So find that parent chain, find and name your substituents. Again, in this case, we only have these alkyl substituents, but we'll introduce more as we go through the course. You're going to number your parent chain. We want the smallest possible number in the name, and then assemble it all together by arranging your locant, followed by your substituent, and then your parent chain. If you got multiple substituents, you arrange them in alphabetical order. All right. We also talked about these special cases where if you have a tie in your parent chain, you're going to pick the one that has the most substituents. And if there is a tie in your numbering scheme, then you break that tie with alphabetical order. Cool. All right, so what you're going to make sure that you have in your notes, or you can even download and fill out this document here. So first of all, sorry, propane, that got deleted somehow. Make sure you have all of these examples that we went through,